Alright, here's a real-world example of when we would be using parametric equations. So let's say I have a car, and it's on a cliff, and let's say we push the car off the cliff, and we want to see the way it descends. Alright, so first let's look at its horizontal component, that's this direction. Okay, so I'm going to let my x of t, my horizontal component, be, I'm starting at 10, so it's going to be 10. Right? And then if I push the cliff, I'm going to be gaining ground this way. Okay, so gaining ground means I'm adding. Alright, now let's say I pushed it with a force of 5 meters per second. Okay, so then I'm going to be gaining 5 meters every second. Alright, now let's look at the vertical component. Now if I throw the car off the cliff, or if we push it, it's going to be losing vertical distance, right? It's going to be falling. So let's have y of t. I'm starting 50 meters high, and because I'm losing vertical distance, I'm going to be subtracting, and in this case, my vertical component, how fast I'm losing, is going to be 5 meters times time squared. Okay, this is a little bit of physics here, so just trust me on this. Alright, now let's look at how our vertical and horizontal components change with time. Alright, so let's let t equal 0, 1, 2, and 3. So, when t equals 0, my x is 10, and when t equals 0, my y is 50. Now that makes sense because no time has passed, so my car is going to be at the starting position. Okay, now if I let t equal 1, then I go over 5, and then if I let t equal 1 here, then I drop 5. Okay, so then I'm going to be about right here. So this is t equals 0, this is t equals 1. Now after 2 seconds, I'm going to be over another 5 feet, so I'm going to be at 20 feet now. And now I will have gone down 20, so now I'm going to be at 30 feet. Okay, so 30 and 20, and that's at 2 seconds. Okay, then at 3, I'm going to be at 25 feet and 5. So 25 and 5 is about right here. And then somewhere over here, I'm going to hit the ground. So this is t equals 3. Like this. Again, because I'm in parametrics, I have a nice direction. Okay, I know that my car is going down. I know that my car is not going from here up. Because I have parametric equations, I can see that the car is going down. Right? Another thing I can see that I wouldn't be able to see if we just use regular rectangular coordinates is I can see the distance between the time. Okay, so let's just take a look at that for a second. So notice how my distance between t1 or t0 and t1 is a lot smaller than my distance between, let's use green, than my distance between, say, t1 and t3. Right? Notice how much bigger this distance is compared to how much bigger this distance is here. Alright, so using parametric equations is telling me that as my car is falling, it's gaining speed. Right? Look at the distance between these points and look at the distance my car has traveled. Okay, my car is traveling a lot faster between T2 to T3 than it was between T0 and T1. Also, if I ask you where is the car at T equals, let's say, 1.5, okay, so where is the car at 1.5 seconds? I can answer that with this equation. Okay, now I can graph the same thing using rectangular coordinates. So let's go ahead and change this into rectangular coordinates. Okay, so I have x equals 10 plus 5t. I'm going to solve for t. So I get x minus 10 over 5 equals t. Therefore, my y value is going to be 50 minus 5 times x minus 10 over 5 squared. Okay, but notice if I asked you anything about time and you were just using this equation here, you couldn't tell me anything because all you have is your x value, your horizontal component, and your y value, your vertical component. You have no time component here. So if I asked you how high up the car was at, like, let's say 20 feet, you could tell me, but you couldn't tell me about the time it takes for the car to reach the ground. So that's one way that parametric equations are very useful and very important. All right, now let's do some examples of finding the rectangular equation when we have parametric. All right, so let's look at this one. So let's go ahead and let's solve let's solve this one for t. So that'd be x over 3 equals t. All right, then if we substitute that in for this t, we get y equals x over 3 minus 1. This would be a rectangular equation. Now, let's say instead of solving this one for t, let's say that we solve this for t. Okay, so another way we could have done it is that we could have said that y plus 1 equals t. I got that from solving this one for t. Right, then if I plug that in here, then I would get that x equals 3 times, and instead of t, I'm going to use this, y plus 1. Okay, so that's two different ways I could have done it. You can do either way, doesn't matter. Okay, so take a minute and try this one on your own. Alright, so let's solve this one. So this one, I'm going to go ahead and I'm going to solve for y. Alright, so that's going to give me y equals t plus 1. If I solve for t on this one, I get y minus 1 equals t. Right, so then if I plug that in here, I get x equals 3 times y minus 1 squared. And this would be my answer. Now let's say I tried to solve it for x. Why didn't I do that first? Well, let me show you. So if I have x equals 3t squared, then when I solve for x, I'm going to get x over 3 equals t squared. Take the square root of both sides. Well, when I take the square root of both sides, what happens is that I get a plus or I get a minus. So that means I'm going to end up with two equations. Alright, I'm going to end up with y equals positive x over 3, and I'm going to end up with y equals negative x over 3. Okay, so let me show you how this would look on a graph. And at the same time, I'm going to show you how you can graph parametric equations on your calculator. Alright, so get out your calculator. Ooh, that's a little hard to see, huh? Alright, so go to your mode, and you'll see that yours is going to be in function. Okay, go ahead and change that to parametric. And then when you do that, when you go to your y equals, you're going to see that you have an xt1 and a yt1. Okay, so let's go ahead and let's graph this one right here. So we're going to have 3t squared for our x value. Our y is going to be t plus 1. Okay, now let's go to our graph. let's change our window. Let's make our t min, let's make that -9. Our t max, let's make that 9. Let's go by a step of 1. Let's make our x min, let's make that -1. Okay. And let's make our maximum 20. And for our min, let's make that -5 and 5. Let's see what that graph looks like. Okay, now notice that this parametric equation wouldn't be a function rectangular, right? It fails the vertical line test all over the place, right? So that's why we have parametric equations, so we can graph these wonderful things that fail the function test. Right, now I'm going to switch back to rectangular mode, or function, and we're going to graph the same thing we were doing. Just a second, my calculator's thinking. Okay, so remember over here I have either the square root of x over 3 or the negative square root of x over 3. So if I do the square root of x over 3 and negative square root x over 3, right, because I had to break it up into two equations, then my graph should look like it did before. See, my graph, when I graph this, I graph the top part first and then the bottom part. The reason it did that is because your calculator will only graph functions, so it has to graph the top part and then it has to graph the bottom part separately. Okay? So now let's look at this one. Okay, so we have x equals t squared minus 2t plus 1. Alright, so right away I'm going to tell you guys that you can rewrite this as x equals t minus 1 squared. Here you can't really see very well, but that's a y equals t minus 1. Alright, so if I go ahead and I solve for x here, then I get plus or minus the square root of x equals t minus 1 plus or minus the square root of x plus 1 equals t. Right, and if I substitute that in here, then I get that y would equal plus or minus the square root of x plus 1, because that would be my t, minus 1. Don't forget to minus that 1. Which would equal plus or minus the square root of x. Alright, so I'd have two equations. I'd have y equals the positive square root of x, and I would also have y equals the negative square root of x. Okay, now let's see what would have happened if I would have solved y for t. So that would have been y equals t minus 1, and y plus 1 equals t. Alright, so if I would have just substituted this in here, then I would have gotten x equals t. Whoops, instead of putting a t, I'm going to put this y. That's going to be y plus 1. That's our t value. Minus 1 squared. So that's going to give me y, or x equals y plus 1 and minus 1 equals 0 squared. Alright, now again, these are the same functions, right? This one looks a lot like this one. You have two equations. Right? You'd be asking yourself, well, we can't graph x equals y squared on our calculator, right? And you also can't graph x equals 3, y minus 1, or x equals 3, y plus 1. And that is true, you can't graph that on your calculator. Okay? Just visually, these are easier. Alright, if you want to graph it on your calculator, then you have to get it into y. Right, so these ones would be ones that you could graph on your calculator. It's when you have y equals the function. Okay, so let's move on to the next one. right? So now we have x equals 3 cosine t, y equals 3 sine t. Alright, now remember that we have that rule that if x cosine of t plus a, y equals 3 sine of t plus k, right? So go ahead and look in your notes and find that equation, that cheat sheet. Then my rectangular formula is x squared plus y squared equals 9. Why 9? Because that is 3 squared. Okay, so along with this, we know that this is a circle with radius 3, and it's centered at, now notice that I don't have an h or a k. Well, I can just add a 0 to both of these, or subtract a 0, doesn't matter, and my center would be 0, 0. Alright, let's look at this one. What if r is negative? Okay, well, using the same formula up here, we're going to have that that's x minus 4, even though 4 is positive here, we'll be subtracting here, squared, y minus negative 5 squared equals r squared. Now it doesn't matter if our r is positive or negative, because when we do that, let's go ahead and simplify. We get x minus 4 squared plus y plus 5 squared equals 4. Okay, so what kind of equation or graph is it? This is going to be a circle with radius 2. It's going to be centered at 4, negative 5. Alright, this is a good habit to get in, is to write down what the graph would look like. Here we have x equals 2 cosine squared and y equals 2 cosine squared. So this is going to take a look, because these aren't in the form that we have them up here. So what if I just took x plus y? Well, I know that my x is 2 cosine squared t. I know that my y is 2 sine squared t. If I pull out this 2, I get 2 times cosine squared plus sine squared t. Remember, cosine squared plus sine squared equals 1, so that just equals 2 times 1 equals 2. So my rectangular equation is x plus y equals 2. Okay, go ahead and pull out your calculator and graph this in parametric form, and see what kind of graph you get, and see if it matches up with this. So if you graphed it, what you should have seen is a line. X plus y equals 2. If we solve this for y, we get y equals 2 minus x. And this equation is just a linear line. Okay, it's just a linear equation on the Cartesian plane. Right, so you should have gotten a graph that looks something like this. Right, so graph will look something like this on your calculator. Now let's work with converting the following to parametric. Okay, so for this one, I'm just going to let x equal t. And then if I do that, then I get that 2t plus y equals 4. Now I still need to solve for y, so I get a function. So when I do that, I'll get that y equals 4 minus 2t. Alright, so the goal of these is to get our y's and our x's by themselves on one side, and have the other side expressed in only. Now this one, while it looks like might expand, or I'm sorry, factor into something nice, it doesn't. So I'm just going to let my y equal my t this time, and x will equal t squared plus t minus 3. Alright, now if I go down here and I do the same thing, I have x plus y squared equals 9. Well, I know that x squared plus y squared equals r squared. So that means that my r is 3, because 3 squared is 9. So that means that my x is going to be 3 cosine of t, and my y is going to be 3 sine of t. Okay, make sure you look at your notes and remember Wegg's equation. Alright, the next video is going to be solving a homework problem.